Welcome back to the GIS lab. I hope you've all been able to log in remotely. So you are going through a virtual private network to access the individual computer assigned to you. If that's still holding you up, please let me know and we will troubleshoot. And if that is getting in the way of a deadline, don't worry about it. Those are targets for now. We'll get it done. So I am actually really glad that we did this little foray into ArcGIS Online for a couple of reasons. One, good to get used to different software platforms. It's like driving a truck or driving a car. If you get used to just one vehicle, you're not that good. You need to be able to drive multiple things. So GIS isn't all ArcGIS desktop. There are dozens of platforms out there. Most of them are managed by Esri. So you have ArcGIS Online, ArcScene, ArcDesktop, ArcGIS Pro. ArcGIS Pro is sort of becoming the flagship now. On top of that, there's Map Info, Map Windows, Manifold. QGIS is open source. Saga GIS, Grass GIS. ERDAS Imagine is more remote sensing. Blue Marble software from Maine. So there are dozens of platforms. All of them, a lot of similarities to one another. Others of them seem almost like they've been designed to be the exact opposite of what you just got used to. But just like driving a car, you become a much better driver if you use multiple platforms. The other reason I'm really glad that we did this whole exercise is that now every one of you has an ArcGIS Online login, which means that you can access datasets that Esri had previously had under lock and key. So to access those, File, Sign In, and then tap in your username and password. And now when you go to File, Add Data from ArcGIS Online, and if you search for Esri, one of the top results is terrain, and that is one that's given us some problems. So we'll hope for the best. Add that bad boy in there. Think, and there it is. Awesome. So we can also File, Add Data from ArcGIS Online, and search for terrain hillshade. And the multi-directional hillshade is the one we want. Gorgeous. Add that in. And now that looks like so. And of course, hillshade goes on the bottom, terrain goes on top. Terrain is displayed with transparency, 50%. Apply. Symbology. Color ramp. Elevation numero uno. Apply. And now, down here, statistics from current display extent. Okay. And now, if we zoom in on the great and good state of Maine, watch how the color ramp changes. From all blue to now we have that. If we zoom in on Aroostook County and adjacent Quebec, now that. So we, of course, are sitting right about, let's see, where are we? Right here. So that's where we're at. So that's the Fish River, that's the St. John coming down, that's a tributary to the St. John, and you can see how the St. John becomes big. So before I mentioned I did like 10 takes of this because I kept getting distracted and thinking how awesome this data set is. And now I want you to actually go ahead and get distracted and do that same thing. So load these data sets in, and I want you to find 10 things that you think are really cool. And I want you to take screenshots of them. No fancy map, none of that. Just zoom around, learn stuff about the world that you can tell just from the elevation. And I'm massively enthusiastic about this because this is so much cooler than any, if you grew up with a desktop National Geographic atlas, fantastic. You can go anywhere with that, but it doesn't change as you flip around. One page will be different from another, but it doesn't change with you. And see up here in the Gaspé Peninsula, they have a mountain that is nearly as tall as Katahdin. Make that comparison here. It's just a little shorter. I've got some white on that, none there. But if we zoom in, you'll see that's the peak. And this mountain, somewhere right in here, this is in it's Gaspésie Provincial Park in Quebec. And this here is Mont Albert. So, Albert Mountain, I believe. I hope. Either this one or this one. How do we find out? One other thing. File. Add data. Add data. Oh, let's add base map. Topographic. And that is the familiar one. That is the normal base map that goes with all of ArcGIS Pro. And see, there was something that was triggering you off wrong there. This is Mont Albert. This one here, Jacques Cartier. And my French is terrible. Sorry. But now we can bounce back here and see this is the one I was looking at before. This is their Mont Albert. And somewhere right in here is a lovely looking hotel that I'm sure you could stay at sometime when all of this nonsense is over. So, lovely hiking up here. Looks a lot like Katahdin with a peak and flat area, tablelands. And then Jacques Cartier is looking a little bit taller. So that would be one of Neil's screenshots. Another thing I really want to do someday is pop across the St. Lawrence and go to this impact crater. Not here. I think here. This is about 120 miles all the way around, and it is, of course, a lake. And if we pop those off and the base map on, what is that called? Oh boy, I'm going to have to pronounce that. Reservoir Manicouagan? I don't know. Mount de Babel, the Tower of Babel in the middle of all that. So this, I'm sure, is a lovely place to find mosquitoes. But you can see the difference between looking at a topographic base map like this and an interactive terrain data set like this. This shows you so much more about the world and how it's put together. So, let's see some other cool stuff. So there's the Central Plateau of Quebec. I never knew this whole high area existed. It's nearly as high as the White Mountains. No idea. No idea at all. That is a really cool 90-degree bend in that river valley. Would love to know what geological process formed that. Probably the edge of something. But you don't normally see a 90-degree turn like that. So we can pop those layers off and our base map on and see what things are called. And again, on a normal topo map, this looks like nothing. But if you went something St. Paul there, you could access that. Looks like there's a road going right up through the middle of that. Yeah, so you could get into that. Yeah, that is looks as high as most of the White Mountains. It's of course more of a plateau, so the relief of any one of those spots is going to be different. Then there's that whole drainage plain, whatever that is. Going around the north, you can see all kinds of fun stuff, but let's go overseas. This data set works around the world. Go ahead and go look at the Himalayas. You can see, of course, Europe has its mountain ranges. There's the, what are those, the Pyrenees there between Spain and France. The Alps. The Alps are obviously a well-known mountain range. They're running from northern Italy up through Germany here. And the Caucasus here, so the Caucasian racial group is actually named for the Caucasus, which is a little interesting because it's nowhere near Europe where you normally think of white people coming from, for lack of a better word. But the people from here, now Many of them are white, but that is the origin of the Caucasian word, the Caucasus. And then, making them all look tiny, is the Himalayan mountain range. And under that is India. So that big plain here, I would guess that's a grassland, but I don't know. But let's see, where would Mount Everest be? I don't even know. Well, one way to find out. Where is Mount Everest on the map? So there's Mount Everest. It's right at the top there. There's Nepal. So right up off the eastern edge of India. So let's go back to our map. Find that northern edge of India, wherever that happens to be. And let's cheat and use our base map. So there's that, there's Nepal. And where did that say it was? So that's where Everest is, in Makalu Barun National Park. Makalu Barun National Park. So there will be Everest. Oop, not responding. Alright, come on, you can do it. There you go. So the tall one, I would guess, would have to be Everest. Now that we're zoomed in on that, we can uncheck that. There's base map, there's the border. Mount Everest. Thank you very much. So that there is Mount Everest. You can see that ice flow out there. If you're interested, you can figure out the access routes from that. All sorts of glaciers. Let's see what kind of resolution we have here. Not awesome. Really not awesome. Oh well, that's okay. But what's curious about that is, well, that is the highest point in the world, of course. It is on top of a massively high range of mountains. Even the valleys in this range are higher elevation than the surrounding countryside. So you can think of that as the Himalayan Plateau. And this, don't even know the name for. Let's see if we can find out. Takla Makan Desert. Oh, so don't get your truck stuck there. Cool. So all of that, let's see if we can find file, add data, add base map, imagery. Let's see what it looks like from up here. Yeah, that looks like it would be really hard to cross. So it looks like we have one little stream running right up the middle of it. And I bet if you were trying to cross that, you would sure hope that would have some water in it. Goodness, that's cool. See if a little sand dune on that. Yeah, we're not in Kansas anymore. Alright, let's let it stop thinking about that and go back to terrain. So, question becomes, why is that a desert? Give you a second to think about it, and then I'll take my best crack at it. So, the flow of the wind is usually going to be from the west to the east, and that's pretty typical, so on the assumption that is true. This is going to be in the rain shadow of all of this mountain range, so it's completely surrounded by high mountains. Whatever moisture is in the air up here, if it's flowing this way, as that air crosses the mountain range, it's going to be compressed and raised in elevation. It's going to become cooler. When it becomes cooler, it can hold the moisture less well. So the moisture is going to fall out of the clouds onto the ground, which means that this is going to be the wet side, if the air is going this way. And when it gets back out over the lower elevation, there's no more moisture to be precipitated. So it's again got more space to expand, it's no longer compressed, it can get warmer again, and that means that there's going to be no rain. So that is why something like this would be in the rain shadow. Take you over to someplace I know well, so I stop making stuff up there. This is where I did my doctoral work, here in central British Columbia. This is the Fraser River here, and this is the Chilcotin River. And this is the Coast Range, British Columbia, and this is, of course, the Rocky Mountains. Jasper and Banff National Parks, if you ever get a chance, fantastic. This lower elevation down here is grassland. This is the Coast Range, as I said, and it's very, very wet here. So, legit temperate rainforests in here, the western red cedar. This is Vancouver Island, of course very warm, and the Haida Gwaii or Queen Charlotte Islands up here, if you're familiar with that. But this is all going to be glaciated in here as it gets cooler, so warm Pacific air drops its moisture out here, gets cold with elevation, forming glaciers here. And where I was working here, and one day I could be working over here, and by the afternoon I could be working over here in view of one mountain range in the morning and another mountain range in the afternoon. Awesome time. So, of course, this is a rain shadow, meaning that all of the moisture has been wrung out here, and it's very, very dry here, and it gets progressively wetter as you go this way. That is also the story of the central part of the United States, which we talked about briefly before. But of course, this is called the wet coast. Washington rains all the time. And you go from a very wet spruce fir type of a forest here, over that into dry ponderosa pine and Douglas fir. As you get into here, higher elevations get more moisture. So in Arizona, you have some mountain ranges that have still ponderosa pine, but it's a little bit wetter than otherwise. Get through Colorado, higher elevations, precipitation again, but not so much. And as you get across here, very dry grasslands here, but then as you get into more circulating air from the Gulf of Mexico, more precipitation again, until you get into Appalachia, which runs all the way up into Maine, and you get more precipitation again. So you get taller grass, shorter grass prairies, and then in here, in Arizona, you have legitimate desert, and Nevada, of course, as well, desert, so Arizona, New Mexico, all of these areas, very, very dry. But if you can get irrigation to them, if the crops have water, they do well. Let's see here. So there's, let's see, that'll be Yellowstone, there'll be the Tetons in there. One of these is the Wind River Range, I think it's this one. Anyway, so that's me dragging around. You can see the old volcanoes around here. I'm going to forget the names of them, but if you zoom in, you can get all sorts of neat information. So yeah, that went boom. Really cool. Zoom in, better and better resolution. Wow. So this just wasn't possible 10 years ago. You could, if you worked for the right agency, maybe look at these kinds of data. But to be able to just scroll around and look at every place in the world and see high-resolution elevation data, if that's just the highest resolution available, but to look at this kind of elevation data and to have it adapt with you as you move around, it would be really easy to take this for granted. But I want you to appreciate how cool this really is. To be able to look at whatever elevation data you want, to have it change with you, be able to zoom in, zoom out, look at all this stuff that before the best you could have done is a coffee table atlas, which again, awesome thing to grow up with, but it is nothing compared to this. This is really awesome. So your assignment, really simple. Find me 10 spots you think are cool, take a screenshot, say where they are, upload that Word document to Blackboard, and that will do for Monday. So really simple, but just appreciate the awesomeness of this data set and what it can do. That might be an oops. Yeah, borders between data sets are always fun. Yeah, explore, enjoy, check out things you find interesting anywhere in the world. We've got data from Antarctica to the Baffin Islands, and sky's the limit. So go exploring. Can't go far right now, but take yourself on a virtual tour and show me where you went. Have fun. Till then, stay safe. Hope to see you soon.